Hello everyone, welcome to this discussion where we have a problem which says an uncomfortably loud sound might have intensity of 0.54 watts per meter squared. Find the maximum displacement of the molecules of air in a sound wave if its frequency is 800 Hz. Take the density of air to be 1.29 kg per meter cubed and the speed of sound to be 340 meters per second. Alright, so let's see how we go about it. Now, in this case, to find the intensity given maximum displacement, we'll say that this will be half. This will be half. Then we have density, the speed, angular frequency squared, and the maximum distance squared, of which this just happens to be our maximum distance. Which we can also consider saying it's the amplitude. Okay, so maximum displacement will just be the same as amplitude in this case. So we're going to find this by simply making it subject of the formula. Okay, so what we're going to do first is, let me clear this. So the 2 we have on the right to multiply with the left. So I have 2 times the intensity is equals to the density of air, the speed, angular frequency squared, and the amplitude squared. So I will divide by density v angular squared both sides. So I have also density v and omega squared like that. So on the right we'll be left with our delta squared is equals to 2 times the intensity over the density, the speed, and angular frequency squared. And then to get rid of the square which we have on the left, we square both sides. Hence this will cancel. We have our amplitude to be equal to the square root of 2 times the intensity over the density, the speed, angular frequency squared. Right now, we don't have the angular frequency, but we know to say to obtain the angular frequency, we can use the expression of 2 pi f, where f represents the frequency. And this will simply give us 2 times 3.142, then multiplied by 800. And this will give us nothing but 5026.548. And the units for angular frequency are rads per second. Okay, so we can now go back to our expression for finding the maximum displacement and substitute the value. So I have square root of 2 times the intensity is 0.54. 0.54. Then the denominator we have 1.29 multiplied by 340 for the speed times the angular frequency is 5026.548. Then we have it squared. So the angular frequency squared. So we now our will be, now upon using a calculator, we'll have 2 times 0.54. Then down there we have 1.29 for the density times 340 for the speed, and for the angular frequency squared we have 5026.548 squared, and our expression gives us 9.87205 times 10 to the power negative 6, which we can just write as 9.87 times 10 to the power negative 6 meters. And this distance is just the same as 9.87 micrometers. Hence we are done with our problem.